Probability example 26. Suppose you purchase a $20 raffle ticket. There are only 4,000 tickets being sold, and one ticket will be drawn to win $3,000 in groceries. What is the expected value for the raffle? So you are not going to get your $20 back if you win. So $3,000 if you win, you have the $3,000 of groceries, and that's nice. But it's going to have to be $3,000 minus 20 because you still had to buy the raffle ticket. So your net gain in this case would be $2,980. If you don't win, you are out $20. So what's the probability of winning? Well, there's 4,000 tickets. There's only one winning ticket. So the probability of winning would be 1 over 4,000. So the probability of not winning is going to be the complement of that. So 1 minus 1 over 4,000 is 3,999 divided by 4,000. So remember, expected value is computed by multiplying each outcome by the probability of that outcome and adding the products together. So we will multiply 2,980 times 1 over 4,000 plus a negative 20 times 3,999 over 4,000. And we get, rounded to the nearest penny, negative $19.25. Example 27 will take us a while, and I think you'll see the reason. In one state lottery, 42 balls, numbered 1 through 42, are placed in a machine and 6 are drawn at random. If the 6 numbers match the numbers a player chose in any order, the player wins $500,000. If the player matches 5 numbers, then they win $5,000. A ticket costs $1. Find the expected value. Now, if you match all 6, remember you're going to get that $500,000, but you did pay $1 for that ticket. So your net gain is actually only $499,999. I hate to say only with that one. Okay, well, what if you match 5? You win $5,000, but remember you paid $1 for the ticket. So your net gain is $4,999. And if you didn't match 6 or match 5, then you lost $1. So now let's look at the probability of the outcome. They said that a player can choose the numbers or match the numbers in any order. So for the denominator, let's look at all the different ways that you can choose 6 balls from 42. Now in the numerator, we're looking for the probability of winning, and there are only 6 winners, and we're choosing all 6. So that comes out to be 1 over 5,245,786. Okay, well that was the easy one. So match 5. Again, it's going to be over 42C6. So of the 6 winning balls, you only match 5 of them. And then there are 36 left. You only are choosing one of those. Okay? So 6C5 times 36C1 gives us 216 over the 5,245,786. And I just want to point out that it would certainly been fine if you just put 36 right here, because it still gives you the same thing. 36C1 is exactly the same as 36. Put that back. Okay, well, what if you lost? Well, first of all, how would we find the probability of that? Well, it's going to be 1 minus this amount right here minus this amount right here. So the way I determined that is I took our denominator and I subtracted the 1 and the 216, and I ended up with 5,245,569 over our 5,245,786. So mathematically what it's looking like is 1 minus 1 over our denominator minus 216 over our denominator. Pretend I wrote that nicely. And then this is what we end up with. Okay, I'm going to pause this and write that out. I'm sure you don't want to listen to me droning on while I write all that down, so let's pause. Okay, so I use the methods for determining the expected value by multiplying our net gain or loss, our outcome, by the probability of that outcome, and we ended up with a negative 70 cents, which shouldn't surprise you. I just wrote this down here just to kind of show you that there's all kinds of ways to mess up when you're putting that in your calculator. And I basically typed the 42C6 when I was putting that in my calculator because it was fewer keystrokes. So that's up to you. Remember, that is that denominator. Okay, let's finish up this video with example 28, which is considerably more simple. According to the Social Security actuarial life table in 2016, a 43-year-old woman has a 1,724 0.1% chance of dying during the next year. An insurance company charges $600 for a life insurance policy that pays a $300,000 death benefit. What is the expected value for the person buying the insurance? Now, look, I get it. She's gone, so this person doesn't get anything. I understand that. So let's just talk about for the family. So we're going to look at whether or not they live or die. Okay, so if they live, then they're out that $600. But if they die, the family gets the $300,000 minus that $600. So they will net the $299,400. So they said the probability of her dying, it was this percent. Don't forget, we need to move that decimal 2 places to the left as we convert that from a percent to a decimal. That is one of the most common mistakes my students make. And then the probability of the outcome of them living is going to be the complement. So 1 minus this amount is going to give us this decimal here. So let's find the expected value. Okay, so remember, I'm going to multiply the outcome times the probability outcome plus the other outcome times the probability of the outcome. And so that would give us a negative $82.80. All right, so that shouldn't be too surprising. Generally, it is still a shock when a 43-year-old person dies, so they wouldn't expect for the family to collect on that particular policy.